Well, statistically speaking, you're probably in a different time zone than me. You're certainly watching this video at a different time than I recorded it. There's a difference there. And so when you're dealing with time, you have to be very precise and very specific about when you saw something, how you saw it, when a file was saved, when a file was accessed. One of the things we want to look at are the offsets of time. Now, if this is the Windows operating system, for instance, Windows uses a 64-bit timestamp, and is a timestamp that counts the number of 100 nanosecond intervals that have occurred since January the 1st January the 1st of the year 1601 at 0000 GMT. Now, obviously, this means that it's going to stop working in about, I don't know, 58,000 years. So if anything, Microsoft was thinking ahead of the game here. You weren't going to run out of time anytime in the next 58,000 years. Maybe by then, we'll have a different timestamp we can work with. In Unix or Linux, we have a 32-bit timestamp to deal with. This recognizes the number of seconds that have occurred since January the 1st of 1970 at 0 GMT. Now notice that this is a 32-bit timestamp, which means it's going to stop working soon. We don't have that many numbers or seconds that we can deal with here. So it's going to stop working on Tuesday, January 19th, 2038. So if you are around for the Y2K type problems, this is more like Y2K plus another 38 years. And it will stop working at 3:14:07 GMT on that day. This is called the year 2038 problem. And obviously we're going to have to update our applications to be able to take this timestamp limitation into account. So there's your challenge there, is that the timestamps, notice, between Windows and Linux or Unix-based systems, POSIX-based systems, very different in the way that they count what time it is. And when you sit down in front of a computer and you're looking at the file and the timestamps, there's also differences on how the operating system is storing those. And different file systems store timestamps differently. In file allocation table, the FAT table, time is stored in local time. That means that whatever the local time is on your computer, if it's 5 in the afternoon your time, it stores it as 5 in the afternoon. You have to keep that in mind when you're looking at the timestamps. If you're using NTFS, the time is stored as GMT, and your operating system changes the time on the fly to show you what your local time is, but the reality is the timestamp of the file is in GMT. So that's another thing to keep track of from a forensics perspective. You also, when you sit down in front of these computers, then you have to know what time zone is configured on the computer so that when you're looking at a screenshot of timestamps, you understand relative to GMT what the actual time is. So you want to look at the Windows registry, which is the ultimate source of where this is stored in Windows. And there are many different values in the registry because you can set a time, you can set what your time zone is, you can set whether you're going to have daylight saving time take effect there, whether it's going to time change information automatically or not. There's a lot to the time. So by storing this and looking at the time, the clock on your computer, you also need to understand what the offset is set to, and then you'll be able to have everything go back to one relative timestamp. Usually GMT is one that we're very commonly using as a standard relative timestamp. But you can see here now how important it is when you're collecting data to make sure you have the correct time and you understand what the time offset is of that computer.